So today we are going to be looking over factoring. Hopefully we recall some of our factoring techniques and methods from Algebra 2. If not, we will review some of them. So hopefully by the end of the lesson, we remember a few more of them. So remember that our first thing that we always want to check for is our greatest common factor. This is also called our GCF. Now, factoring out our greatest common factor allows us to simplify our expressions before we simplify them any further, or in some cases, our factoring out our GCF is our only form of factoring. So in our first example, we have 6x cubed minus 4x. So notice that 6 and 4 have a greatest common factor of 2. And then x cubed and x have a greatest common factor of x. Remember that our greatest common factor can be both numbers and variables. So in this case, it would be 2x. Then we can think of factoring kind of like dividing. So we're going to write whatever we have left over inside of our parentheses. So in the case of this problem, we would take 6x cubed divided by 2x, and we would be left with 3x squared. If we divided negative 4x by 2x, we would be left with negative 2. We always want to check and make sure that we cannot factor any further. 3 and 2 do not share any common factors besides 1. It is a binomial because we have two terms, and we do have an x squared there, but none of those are perfect squares, so we can't use our perfect square formula, which we will be going over that in just a few minutes. So on question number B, notice that this time we have 3 terms, so we have a trinomial. So our greatest common factor has to be shared with all 3 of those. So notice that my first 2 terms have x's, but my last one doesn't. So we can't factor out anything with an x. However, 4, 12, and 16 all share a common factor of 4. So if I factor out, or think of it like dividing out of 4, I would be left with negative x squared plus 3x minus 4. Now remember that we can always factor out a negative. In this case, it might be a little bit helpful to factor out a negative because that's going to turn our leading coefficient positive, which sometimes we want just because it makes it a little bit easier in whatever else we might be doing with those factors. And then we want to check and make sure that that resulting trinomial doesn't factor, and in this case it doesn't. So that would be our final answer. In our last example for this page, we have x minus 2 times 2x plus x minus 2 times 3. So notice that this time my 2 terms, so remember terms are separated by addition or subtraction. We have 2 terms, and within those terms, they do have a common factor of x minus 2. So in this case, our greatest common factor is an expression, not just a single term this time. And we can factor it out the same way. So they both have an x minus 2. So that's what's going to get moved to the front. And then we're looking at what we have left over. So in this case, we have a 2x and a 3. So in our second set of parentheses, we get 2x plus 3. Again, checking to make sure that nothing else can be factored out, and it can't, so that is our factored form. All right, so we have 3 minus 12x squared. Our first step is we want to check and see if we have any greatest common factors, which we do. 3 and 12 have a common factor of 3, so we want to pull that or factor it out to the front. So then we're going to be left with 1 minus 4x squared. Now notice that we have a binomial there. And 1, 4, and x squared are all special because they're all perfect squares. And we do have a special formula for when we have a binomial, they're all perfect squares, and it's subtraction. So our formula, if I have a squared minus b squared, it's going to factor to a minus b times a plus b. In this case, if we're looking at our two terms, the 1 is pretty easy to tell that that would be 1 squared. Our second term is a little bit harder, but not too much. So remember that 4x squared could be written as quantity 2x squared. So now it's a little bit easier to tell that our a value for our formula is going to be 1 and our b value is going to be 2x. Now you don't always have to rewrite it out like this with the 2x in parentheses. Just for this example I did because it's our first time going over it, and so it helps us to be able to connect our problem with our formula. So our a value is 1, so I have 1 minus our b value, which is 2x, in my parentheses, and then I have 1 plus 2x in my second parentheses. Again, checking to make sure that there's not anything else that can be factored, and it can't, so that's my final answer. Just like with our first problems, sometimes what we're factoring is not necessarily just going to be a single number or variable. It can be an expression. So in this case, our a value is x plus 2, and our b value is y. But it doesn't change our steps. We're still going to use that same difference of squares formula. So we have parentheses. Our a value is x plus 2. Our b value is y, so minus y, times our second parentheses. We still have that x plus 2 because it's still our a value, but then we want to add our b value, so plus y. And anytime we have an expression, we want to make sure that nothing simplifies or we don't have any like terms. So I'm just going to rewrite it with our numbers at the back because it kind of makes it easier to tell, and we notice we don't have any common terms. Nothing can be simplified any further, so that would be our answer. So for our next one, it's not quite as easy to tell what's being squared. So again, I'm just going to rewrite so we can see it a little bit easier. So for 16x to the 4th, we could rewrite that as 4x squared quantity squared minus 9 squared. And so now it's a little bit easier to tell that our a value is going to be 4x squared, and our b value is going to be 9. So again, applying that handy dandy formula, we get 4x squared minus 9 times 4x squared plus 9. And we've heard me repeat it several times now, and in this case it's important to look and see, does this factor any further? Because if we notice our 4x squared and our 9 is another set of perfect squares. So we can use that same difference of perfect squares formula again. So we would get 2x minus 3 times 2x plus 3. Now, notice in that last set of parentheses, even though 4x squared and 9 are all perfect squares, we have an addition symbol there. And so because of that, we can't factor it any further. We don't have a sum of squares formula. It just doesn't factor, and so that would be our final answer. All right, so then we have trinomials. So hopefully we recall that trinomials means 3 terms. There are a couple of different methods or ways that we can factor trinomials. And as long as we're showing all of our steps and using correct mathematical ideas and rules, as long as we are doing all those things, it doesn't matter how we get there. However, the method that I'm going to use whenever I factor trinomials is called our AC method. So you're welcome to follow along with this method, or like I said, use another method that you're more familiar with or just understand a little bit better. Some of us might just be able to look at those trinomials and be able to factor them in our heads. That's always our goal, but if we can't, that's okay. We'll get there eventually. So with our AC method, the biggest thing to recall is that when we have a trinomial, especially a quadratic trinomial or a degree of 2, our general form is ax squared plus bx plus c. So when I talk about a and c, I'm talking about those coefficients, the leading coefficient of a and my number of c. So my first step is going to be to multiply a times c. And I want to find two numbers that multiply together to give me a times c, and a same set of two numbers that add together to give me b, or that middle term. So remember that when I'm talking about a, b, and c, I'm only talking about the number. The x's don't go with it. So in our first example, we have x squared minus 10x plus 25. So notice that my a value is 1, my b value is negative 10, and the c value is 25. So I didn't include the x's, but notice that for our b value, I did include that negative. So the negatives do have to be included. So a times c is going to equal 25. So then I'm looking for two things that when I multiply them together, I get 25. And when we add them together, we get negative 10. Now, I can just see right off the bat that those are going to be negative 5 and negative 5. If we didn't see that, we could always run through our factor tree or factor chart of 25 to figure out which combination of factors gives us negative 10. Now, what we're going to do is with those two special numbers that we just found, we're going to use those to replace our middle term. So instead of writing the negative 10x there, I'm going to write x squared minus 5x minus 5x plus 25. And the reason that we do that is because now we can separate into two groups. And when we do that, notice that my x squared and my negative 5x have an x in common. So I'm going to factor that out just from that first parentheses or that first group. And we'll be left with x minus 5. And our second group, they have a negative 5 in common. So I'm going to factor out that negative 5. And I'm left with another x minus 5. And then just like the example that we looked at before, notice that they have an x minus 5 in common. So we can factor out that parentheses out to the front, x minus 5. And it just so happens that we are also left with an x and a negative 5. So we would have x minus 5 in our second set of parentheses as well. The other way, hopefully we remember that we can rewrite this, is squared. So we have x minus 5 quantity squared. Now,